Hi, Algebra people! I hope you guys are having an awesome day. And lucky you, today you get to learn Algebra 2, which is so exciting. I bet that adds to your awesome day. Um, so today we're going to learn how to multiply polynomials. And I'm going to give you 3 different ways to do it, okay? And you pick whichever one makes the most sense to you. You can pick and choose based on the problem as well, but just like don't mix up the different methods, because if you use both of them at the same time, then you might mess things up. So just make sure you pick one method and you stick with it. Okay, so anyways, we're going to take 2 polynomials and multiply them. Okay, so good talk. All right, so let's find a polynomial. Let's pick the polynomial, I don't know, 3x cubed minus 2x plus 1. And we're going to multiply that by x minus 1. We'll start simple. Okay, so that's going to be our first problem. Okay, so option 1 is multiply horizontally, and this is basically like extreme foiling. You know how with FOIL you have 2 terms, you have like x plus 1 times 2x minus 1, and you FOIL. You got the first and the outer and the inner and the last, right? Extreme foiling is basically the same thing, but like say for example, instead of 2 terms we have another x squared and a 5x to the third, right? Instead of having first, outer, inner, last, we have this x has to multiply by everything in the other term. So you do that times that, times that, times that, times that. Kind of got like a rainbow thing going on. And then we have like a cup thing going on the other direction. That times that, times that, times that. And then you add them all up and simplify. Okay, so that's the horizontal, is like extreme foiling, also known as distributive property, but I like extreme foiling better. So you can try it for the next problem, for the problem that I gave you guys. Try it, see if you get it right. It's not too bad. Stuff that we've been doing before. So, in case you need the steps, I've got my first thing, I've got x times 3x cubed. Well, x times 3x cubed is 3x to the 4th. So you get 3x to the 4th from that. And then the next term is negative 2x times x. So that's minus 2x squared. X times 1 is x. And then we have to add the stuff. We have to take this minus 1 now and multiply it by everything. So minus 1 times 3x to the 3rd is minus 3x to the 3rd. Minus 1 times negative 2x is positive 2x. And then negative 1 times positive 1 is minus 1. So then you want to simplify and write in standard form. I'm going to just say, like, you should probably always write everything in standard form. If it starts out not in standard form, write it in standard form. Even if I don't ask you to do it, you should just do it. Okay, it's like simplifying square roots, you know? Square root of 25, you shouldn't leave as the square root of 25. You should say, oh, that's simpler when I make it just a 5, right? I'm not going to tell you you have to do it, but it's just kind of assumed. Anyways, so then we simplify, right? 3x to the 4th, you want to look and see, are there any other x to the 4th? Are there any other like terms that I can combine together? And there are not, so I've got that 3x to the 4th. And then next would be a cubed power. So I've got this minus 3x cubed, no other x cubes, so that's next, minus 3x cubed. And then x squareds, minus 2x squared, no other x squareds, minus 2x squared. Now I have here, I've got an x and a 2x, and those need to combine to make a 3x and minus 1. And so that, my friends, would be the answer. And that's the horizontal method. So now we're going to do the exact same thing, but with 2 other methods. Yay! I hope you're really excited. Okay, so if we're going to multiply them vertically, like this, you want to set it up as a vertical. So it's like the same way you multiply like 321 times 11, right? You do that times that, that times that, that times that, and then you move over one, and then, you know, it's the same process, okay? But yeah, I guess you don't need to do that. Okay, good deal. Ignore that last moment. Okay, so we want to set it up. I like to put the longer one on the top. It helps me see things better. So I have like a 3x cubed minus 2x plus 1. And then I have a multiplying by x minus 1. I'm going to do a dot like that instead of an x for multiplication because I can see that being bad. Okay, so then you want to do 1 times 1, negative 2x times 1, 3x times 1, like you would a normal multiplication problem. Okay, so 1 times negative 1 is negative 1. Negative 2x times negative 1 is positive 2x. And then the 3x cubed times negative 1, that's negative 3x cubed. Okay? And then you go down to the next terms. You do 1 times x, negative 2x times x, and 3x cubed times x. Again, so I'll just like shift this down a little bit. I've got 1 times x, which is just x. And it's nice if you like line them up under the things that like match. Anyways, 1 times x, x. Negative 2x times x is minus 2x squared. And then you've got a 3x cubed times x, so that's, we don't have a cube power, so the lining up thing doesn't really work. Anyways, ignore that. 3x to the 4th, okay? Add all of those up, and you've got that minus 1. You can see that the only terms that I have in common are the 2x and the x, so that's a 3x. Then I've got this minus 2x squared, and then minus 3x cubed, and then the 3x to the 4th. Oops. And hopefully that's the same answer. Got a plus sign in there. Same answer that we got before. And it is. Sweet deal. Okay. That's what we hope for. And the last method is the table method. And this you basically make, like, based on the number of terms you have, you make that size of a table. So I have 2 terms here, and I have 3 terms here. So I make like a 2 by 3 table, or like chart, box type thing. And I want 2 by 3. Okay. And then I put my 2 terms from the x minus 1 here, x and a negative 1, and then I put my 3-term polynomial at the top. So this is a 3x cubed, a negative 2x, and a positive 1. And then you just multiply within the boxes, and at the end add up what's in the boxes. So some people like this if they're more visual and they like seeing things broken down. Doesn't really matter what you use. So like in this box, you would do 3x cubed times x, okay? So that would be 3x to the 4th. Then in this next box, you do negative 2x times x, which is minus 2x squared. And then in the last box, you do 1 times x, which is x. Then in this bottom box, I do negative 1 times 3x to the 3rd, negative 3x cubed, and then negative 1 times negative 2x is positive 2x, and then a minus 1. And then you add all of those together. And you can kind of see that you've got an x to the fourth term, then an x to the third, then an x squared, and then, hey, I've got two x terms, so you can combine those together, and then you've got this one constant term by itself. So it sometimes is easier to see visually, standard form, and which terms you can combine. So I've got this 3x to the fourth minus 3x cubed minus 2x squared plus 3x minus 1. And yet again, we get the same answer that we got in all of the other problems. All right, so now you've got a couple examples, 4 examples, for you to try. I would recommend pausing right now, trying them, making sure you can do it on your own. It's really not that hard. So yeah, try them. I'm not going to really talk through the rest of the solutions. I'll write out the rest of the solutions. Let me know in class if you want to go over any, but I think it's pretty self-explanatory. Okay? All right, I'll see ya. Oh wait, I'll see you in a couple seconds when I write the answers down. All right, number 1, 3x to the fourth plus 9x cubed. Number 2, I did 1 through 3 with the distributive property with the extreme foiling, just because they were laid out nicely that way. The last one I did the box method. Anyways, number 2, I got a cubed b plus 2a squared b cubed minus ab cubed. Number 3, and these you didn't even have to combine anything, so they're pretty easy, as long as you multiplied things and not, added. 3 times 4 is 12, not 7 kind of thing. Okay, so 3, that's the answer. And then number 4, I did the box method, which I set it up, the first polynomials at the top and the second polynomials on the side. And then I highlighted in the same color the like terms so that you can see that. So I've got 1, 2x to the fourth, and then in the yellow you see the 3x cubed minus 4x cubed. Those combine, you can only, so you get a negative x cubed. And then the diagonal 3. And no, this is not always going to happen this nicely, all on a diagonal, if you notice, right? That's not going to always happen. It just depends on what the original problem is. And then the dark and the greens, right? My minus 2x squared and my positive 2x squared cancel, so I'm just left with negative 6x squared. 4x plus 3x is 7x, and then you've got that minus 2 at the end. You combine them, write it in standard form, and voila, you are done. Okay, that's all. Have a lovely day. Bye-bye.